Hello and welcome to another exercise of converting numbers from one base to another. This will be our last exercise in this particular area. So let's say I have a number. Let's play around with. Let's take a number which we call, let's say, 27. So I have 27, which is base 10, and now I have to convert it into base 2 number. So how would we do that? Just from our previous exercises we know that we will take 27 and we divide it over a special division method in which we remember so that will be 13 times 2 can go, because first we are trying to convert 27 base 10 to what would it be in binary. Okay, so we are finding the equivalent of 27 base 10 in binary. So we divide it by 2. Let's go back again, divide it again. That would be 6 times, and then with the 1 left over, divide it again. We will get 3 with 1 left over, and then if we divide it again we get a 1 with 1 left over. Oh, sorry, when we divide it in here, our leftover was 0, because when we divide the 6 by 2 it goes in 3 times with leftover of 0. So what do we have in our hand is, as we have discussed before, we have this one is our most significant number here, or number most bit, so that will go on the leftmost part, and then we will go up from there. So we'll go up from there. So we get 11011 base 2. So what do we have? We had 27 that we converted. So our conversion says that 27 base 10 is equal to 110112. Did we do it correctly? So let's check it out. Now take this 11011 base 2, and as we have discussed before in our conversion, we will write down each digit in its place. Sorry, I forgot the 11011, and then we write powers of 2's on top of them. It's just a quick way to do that, because there's 2 to the power 0, 2 to the power 1, 2 to the power 2. Each respective digit is a new power of 2, just like this is a 7 multiplied by 10 to the power 0, and then this is 2 multiplied by 10 to the power 1. So when we do that, this is basically 2 to the power 4. So in here we get 1 to the power 4 is 16, 1 2 to the power cube is 8. Here we have 2 to the power squared, which is 4, and we have 2 to the power 1 is 2, and then we have a 1 which is 2 to the power 0, right? Now then we say that the ones that have zeros in there, we don't need them, and we will add these numbers now. So we get 16 plus 8 is 24, 24 plus 2 is 26, 26 plus 1 is 27 base 10, and that is what we get when we convert a binary number into decimal. So this is how we convert it back. Now let's check it out and see if we can convert this binary number. So in our hand, we will just play around with the same number. In our hand we have 1011 base 2, right? And now we want to see how much would that be in base 8. What would be its value in base 8? If you all remember, to convert a binary number in base 8 or octal number system, we combine them in groups of 3, right? And then here we don't have anything, so we will do that way. Why? To understand this, you will have to watch my video where I have explained the octal number system. Here, so in base 8, because in octal number system, we can only use numbers from 0 to 7. And the numbers can be explained, can be in binary says these number can only be represented, all of them can be represented at most the 3 bits. So that's why we group them in 3 bits. And for further explanation, you might want to take a look at my octal number system video. Okay, so we come up in here. So these 3 together would be, if I had to convert them, this is 2 to the power 0, 2 to the power 1, 2 to the power 2, and this group will start new because this is just a new group. 2 to the power 1, 2 to the power 2. So we get, each one will be converted differently. So this is 2 to the power 0, 1, and this we will cancel, 1 plus 2, and this will be also, this will also be 1 plus 2. Okay, let me just write it down clearly in here. We are going to cancel this one. So we have 2 plus 1, 2 digits, because we were able to make two groups of them. So we say, what do we get? We get 1 1 0 1 1 base 2. So far we have converted, and that is equal to 27 base 10. But if we write down it in base 8, we will have to have 33 base 8, right? Did we do it right? So let's take the 33 base 8 and check it out. Is it 27 in base 10? Because if it is, then we have done a good job. So how do we do that? We take this 33, we write down 33, the digits in there. Now what is their base? Their base is 8. So we'll write on top of them each base number. Then starting from the right hand side, we start giving them place values. So this is 8 to the power 0, which is 1. So we have in our hand 8 multiplied by 3 plus 8 to the power, 8 to the power 0 is 1. So that would be 1 multiplied by, made a mistake in here, because 8 to the power 0 is 1. So that would be 1 multiplied by 3. And 8 to the power 1 is 8. That is 8 multiplied by 3. So we get 8 plus 8 times 3 is 24, plus 1 times 3 is 3. We get 27. So we were correct. We were correct. So look at it whichever way you want to. It comes up the same thing. Now let's take a look at our number 11011 base 2 and see what in the world is it in hexadecimal or base 10. Base 16. Now in hexadecimal, you can use digits from 0 to, you have to have 15 digits. So what we do is after 9, we start using A, B, C, D, E, and F to have full 16 digits, because after you only can make groups after you get 16 digits. Now to understand it further, please watch my video where I have explained the hexadecimal numbers. So if I come in here, then I will say that, okay, so the number that we have to represent, or the count that we have to represent, is 0 to 15, and the maximum number can be expressed using 4 bits, right? So what we do is we take our binary number and kind of group it into 4 bits. So let's take this guy and then convert it into corresponding hexadecimal digits. This one kind of is just the lonely one. So what do we do here is, for this guy we say that will be 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 4. Then this will be 2 to the power 0, and I'm not doing rest of them because they are just zeros. So 2 to the power 0 is 1. That one was easy. What is this? This is 2 to the power 0 is, we have 1 times 1, we have 2 times 1, we have, well, they are not going to take this, and we have 2 to the power 4 is 16. This should be a cube, I am sorry, and that should be 1 8. I'm not going to put that in here. Now at the first number, so if we add 8 plus 2 plus 1, it is 11, but in hexadecimal we should be using only a single digit, and we know that after 9, 10 represent 10, A represent 10 and B represent the 11, so we get 1b to the power 16. So what do we get so far is, if we take 11011 base 2, that is equal to 27 base 10. It is also equal to 33 base 8, and it is also equal to 1b 1b base 16. Okay, now is it correct? This 1b base 16 actually give us the 27 base 10. Let's check that out. Does it actually give us the base 10? So for that purpose, what we have to do is we have to check that out. Now take this number 1 and b. What base are we talking about? We are talking about base 16, so that should be 16 to the power 0, and that should be 16 to the power 1. So far so good. Now what is 16 to the power 1 is 16 times 1, right? Plus 16 to the power 0 is 1, and we know b in count is 11. Okay, so we have in our hand 16 plus 11, which is equal to 27 base 10. So whichever way you are going to convert your numbers, you are coming back in the same way. You are getting the same number back. So represented, the count L will still be, you have 27 things if you count by decimal, but these things will be represented as a group of digits like this. If you count in binary, they will be represented as a group of digits like this if you count by eighths. If you count by tens, like I said before, that is what we are most used to. But if we count by 16s, which is hexadecimal number, that would be this number. So all of them are representing the same quantity. So I hope you guys understand this particular discussion about number conversions, and you understand that from one base to another, it is a very simple thing to do a conversion. Now I will do further in IEEE representations of binary numbers, and I will also do how would we represent a decimal or fraction in a binary number. So that will be for the next video. Thank you. Bye bye. Subscribe my channel if you understand the material, so that I can make more videos for you all.